Alright, chemistry students, welcome back. Today I'm going to walk you through some limiting reagent practice problems. So, in order to walk through this process, we're going to start with what we know so far about stoichiometry, because all limiting reagents does as a process is to add one extra step into the stoichiometry problem process. So far with stoichiometry, our process is to convert whatever we're given in the problem into moles, if necessary. If it's already in moles, it's not necessary to do so. Then 2, use the mole ratio from the balanced equation to convert from moles of one substance into moles of another. So we convert into moles, then we use the balanced equation to compare the coefficients of one reactant or product to another. Then, once we have converted into the substance we want, we then convert out of moles if the problem demands it. So, all that's really new to stoichiometry is this middle step, is using the mole ratio of the balanced equation to convert from one reactant or product into another. In order to do that, you have to be in moles, which is why steps 1 and 3 are necessary. So all limiting reagents adds to this process is we can think of it as adding a step 0 to this process, really, which is that in order to properly solve the stoichiometry problem, we need to find the limiting reagent. Like we said in the last video, if we're not using the limiting reagent, we're going to come up with the wrong amount of product, because we need to determine which of the reactants is going to be used up first in order to figure out exactly how much product we will make. Remember the example with the toy cars and the wheels we did in the last video. If you haven't watched the last video, it'd probably be a good idea to watch it. So we need to find the limiting reagent. We know we need to find this because it will determine what our correct answer is at the end here. So there are some steps to finding the limiting reagent, which is part of our step 0. So we're going to split step 0 into some sub-steps. So, in order to find our limiting reagent, what we're first going to do is to convert everything into moles. You'll notice this is a common trend. It's going to be pretty common, both in chemistry and in your SOL, to work with moles in most problems, in most cases. So, converting to moles is usually a good step for almost every problem, but to reiterate here, that's what we're going to be doing. So we'll convert everything into moles. Then, for step B, we can select either reactant from the problem. We're going to know that these are limiting reagent problems because we're going to be given amounts of 2 different reactants, which is how these limiting reagent problems differ from the ones we've been given. In our old problems, we were just given an amount of one reactant and we're told to find an amount of product. Well, now we're being given amounts of 2 different reactants and we need to find which of them is limiting. So, for this process, it doesn't matter which one we select at the beginning. We can select either one. At the end, it will show us which of the reactants is limiting, no matter what we do. So, in step C, we have to do our own stoichiometry problem in order to find out how much of the reactant that we need in order to use up all of our reactant. And then we will compare what we need, the amount we need, to the amount that we have. So, then after that, we just need to use a little bit of logic to figure out which one is the limiting reagent. If we need more than we have, we don't have enough. We don't have enough of that reactant. Therefore, if we need more of a reactant than we have, that makes the reactant limiting. It limits how far the reaction can go because it will be used up first. If on the other hand we have more than we need, that reactant is in excess. We have extra of it, which means that our other reactant will be the limiting reagent because the one we have excess of will not be the limiting reagent. So, I know word-wise that sounds confusing. I just wanted to write out a written process so that you could see it. As a problem, it's not that much more difficult than what we've been doing, and let me show you how we do it. So let's take an example problem here. We'll go through our tried and true example of the Haber process, and we'll use this as a limiting reagent problem. We'll say if we mix 10 grams of nitrogen gas with 10 grams of hydrogen gas, how much ammonia will be produced from the above reaction in grams? This looks pretty similar to the problems we've been doing. So the question is, first, how do we identify that this is a limiting reagent problem? And the way we identify that is that we have an amount of two different reactants. We're given two different amounts. This is what tells us that we are working with a limiting reagent problem, because if we didn't figure out which was limiting, which one would be used to solve the problem? We don't know. We have to find it in order to go on. So we have to establish step 0 here, which is find the limiting reagent. We're first going to do step A and convert everything into moles. So since everything's in grams here, we'll use the molar mass to convert to moles. 1 mole of N2 weighs 28 grams, which means that 10 grams of N2 is 0.36 moles. And we'll go through the same process with H2, which is we'll convert hydrogen gas into moles. 1 mole of hydrogen weighs 2 grams, which means that we have a total of 5 moles of hydrogen gas. So then we've converted everything to moles. So for part B, we can choose whichever reactant we want. I'm going to choose nitrogen because it was the first one that I wrote down. It really wouldn't matter which one we chose, because logically we could solve for either one. So we'll choose the amount of nitrogen we have, and then we'll do part C, which is we'll use stoichiometry to find out how much of the other thing that we need. So we want to find out how much hydrogen in moles that we need in order to use up all of this nitrogen. So if we used up all 0.36 moles of nitrogen, how much hydrogen would that require? Is the question that we're asking in parts B and C. In order to do that, all we need to do is a simple mole ratio. For every mole of nitrogen we use up 3 moles of hydrogen. So they are in a ratio of 1 to 3. We insert that into our railroad diagram. Moles of nitrogen goes on the bottom because it needs to cancel. And we multiply 0.36 moles of nitrogen times 3 moles of hydrogen gives us 1.07 moles of H2. So to recap, that means that in order to use up all of the 0.36 moles of nitrogen that we have, it will require 1.07 moles of H2. So now we need to look at part D, is we need to compare what we need to what we have. So we need 1.07 moles. We have 5 moles. So we have more than we need. We have 5 moles. We only need 1.07. That means we have an excess of H2. We have more H2 than we need. So if we have more H2 than we need, if H2 does not limit us, that means that N2 must limit us. It must limit the progress of the reaction. Therefore, we can determine that because H2 is in excess, N2 must be limiting. Our nitrogen gas amount must be the limiting reagent. So, just like in the car example we did, once we have our limiting reagent, we need to use that amount to figure out how much product we will make. This 10 grams of H2 is no longer relevant. We only need the amount of N2 that we have, and that will tell us how much product we make. So now we can do our stoichiometry problem because we found the limiting reagent. So we'll convert our amount of limiting reagent into moles. We already know that that's 0.36 from above. Then we'll use the mole ratio from the balanced equation to convert from moles of N2 to moles of NH3. So 1 mole of N2 creates 2 moles of NH3. That's our mole ratio step in the middle. And then finally, step 3 is we convert out of moles to get what the problem demands. The problem demanded the answer in grams, so we convert from moles to grams using the molar mass of NH3, which is 17. So that gives us 0.36 times 2 times 17, and that gives us a final answer of 12.24. We will produce 12.24 grams of NH3 from this process. So that is how you do a limiting reagent problem. I will post another quick video showing you this same problem and showing you what would happen if we started up here, because the answer is it ultimately wouldn't. Ultimately, we would find out the same thing from that work. We would find out that nitrogen gas is limiting. As soon as we know which reactant is limiting, the only thing that matters from the initial problem is how much of the limiting reagent you have. the amount of the excess reagent doesn't matter, because this will get used up, and as soon as all of this nitrogen gas is used up, we can't make any more product. So I know that this is, as a process, adds a lot more thought, a lot more thoughtfulness to your work. Don't be afraid of that. Embrace it. You know more than you think with this stoichiometry stuff, and you'll be able to figure it out. So, to recap, when we do these limiting reagent problems, you'll find the limiting reagent using these steps. You'll convert the limiting reagent into moles. You'll then use the mole ratio to find out how much product you will be able to make, and then you'll convert that amount to moles, convert that amount out of moles into what the problem is asking for. I hope that has been helpful. Let me know in class if you have any questions, and we'll talk about it in detail tomorrow. Thank you.